So in the example 3, let's see how we use the indirection operator to access the value of the referred variable through the pointer variable. So we can see here we have x is int x variable equal to 25. So we can initialize our int pointer to the no pointer. Or later we can update that. You can just initialize and assign to the x to refer to the x. So afterward, you can see you can access the x value through the x. And because the pointer refer to the memory location for the x, using the asterisk indirect operator, they also can access the value x variable. So we can display like that. And also, not only you can display using the indirect operator, you also can using this indirect operator to assign the value. So when you assign the value, actually you are not assigning 100 to your pointer variable. You are using this pointer variable to dereference to refer to the location for the x. Then they update the value of the x from 25 to 100. Then you can see again, when we display the x again, you will see they become 100. And you're using the reference pointer, you will display they are still 100. Of course, the sample output will show you. But the most important thing, I want you to pause the video and to run the example 3 on your IDE. So then we can see here. You can see this one is our x equal to 25. We can declare our pointer equal to the no pointer. Then we assign this pointer to refer to x. But also, like I said, we also can do this way, right? We can declare this pointer. And at the same time, we assign the location for the x to make the PTR, the pointer, refer to the x variable. So after we do that, you can see you can display the x still 25. You also can using the dereference PTR operator associate with your pointer variable. So this one also refer to the value for the x. So they will display 25. Then if I change the dereference PTR equal to 100, actually they will update the x value become 100. Then we see that they display like that. So then you can run the program. So when we run the program, you can see the output. Right. Before we update, we just assign the PTR refer to x. So x equal to 25. By using the asterisk PTR, they also equal to 25. So after we're using the asterisk PTR to assign equal to 100, then you see x value change to 100 as well. So that's how we do the indirect operator to access our referred variable. And this one is very important for C++. A lot of time in C++, we are not only want to access by the copy. If we want to access by the reference, we're using the pointer variable. After you understand the pointer variable actually just refer to the address for the variable, then the next one I want to talk about the relationship between array and the pointers. Before, we don't have too much time to talk about array, because the array meaning is you have a collection of the data. But here I want to talk about array again is focused on the array name. You will see the array name after we declare an array. This array name actually is referred to the beginning of the memory location of the collection of the data. And this array name actually works similar like a pointer. We see how they will do. Let's see the array relationship with the pointer. So here I want to show you the array. You can see this one, array name start with the address of the array. This one we don't talk about too much, so let me focus on that to show you what means the array name is the starting address of the array. When I declare an int array called vals, so then you can see here we have the brackets 4, 7, and 11. So we initialize an array called vals, and we have 3 int data type. So that's why you see our array we have 4, 7, 11, right? And also before I told you, right, we can using the vals index 0 to refer to 4. We can use the vals index 1 to refer to the 7. We can using the vals with the square bracket 2 to access 11. So that's to access the element one by one. But here, what I want to continue to talk about is the vals array name. What is this array name mean? So actually, when we have the vals array name with the square bracket, we are trying to access the element one by one. But if you have only for array name alone, this vals array name refer to the beginning of the array memory location. For example, if the vals start from memory location start from 4800, you see, then you see 4 bytes, you have a 1 int variable. So if we say this one is 4800, then this line will be 4804. Then this line will be 4808. Let me write it down. So that actually means this location is 4800, right? Good. So then continue. You see this line. So 4 bytes for 1 integer. So that's why here for this line is another 4 bytes. Okay, so then this line will be another 4 bytes. So actually when we have our square bracket to access the index one by one, actually we just do some memory location calculation. So we start from 0, that means I have 4800 start from this line. I read 4 bytes, so then I read 4. So when I'm using the index 1, so then I just know I moving from vals, this location, move 1 index, 1 integer variable. So then start from this line, I read 4 bytes, so I get 7. So the same thing, vals 2, that means I start from vals location, I read 2 integer variables, so then I get 4808. So that's really mean how we're using our square bracket. But here you need to know, when you have square bracket, you access element one by one. But for the vals alone, this array name, they will just see out. When you do the see out, they display the memory location. Of course, that's the idea, right? We show you the concept, but the most important thing we need to confirm with our program. So here I have the program example 4. We have our numbers array. We have 1, 2, 3, 4, 5. We have 5 location. We have 5 elements. So then you will see here, actually we will do the cout numbers only. You will see they will display the location. They will display the memory location for the beginning of the numbers. So then continue. Now we will tell you your array name actually work like pointer. Right, why not? Because you see vals is a location holding the memory address, right? So did you remember earlier we told you pointer variable holding what? Holding an address. So that's why vals is the array name. They display the memory location. So actually the array name actually just work like a pointer. So on the other hand, if this pointer, I do the dereference operator, so then, right, so they will from this location, I will dereference. So dereference, they will read this memory address location for the 4. So when you only do your array name with the dereference symbol, they will display the first element for the array. So then one thing is, like we say, our pointer just work like an array, right? So now actually we can have another pointer variable. Of course, this pointer variable data type should be what? Should be the same as your array int data type. So your array name actually exactly just like a pointer. So that's why your pointer after define, if they assign 2 equal to the array name, actually this one will refer to the beginning of the array. And this pointer, not only you can using dereference to dereference that, and also pointer variable also can associate with the square bracket operator. So then this square bracket operator also displays 7 as well. We see example 7. We see example 4 first. So let's download example 4. We see example 4. So we define an array. You have 5 elements. Each one is int. So when you just see out your array name, so then later you will see they will just display the memory location. So this array name, if you try to dereference, they will dereference to the first element of the array. So then we will see here, right? So you see the location for the array is the big number. So if I only do the dereference for the array name, they just dereference the first number. But continue, if I want to dereference, you see here, I have our numbers, right? Okay, so this number, like we say, we can have another pointer. So this PTR, that's assigned, this int PTR, they are the same data type. So that's why this PTR can assign to the array, beginning of the array name. So now here, if I want to using the array name to a pointer name to refer to the array, right? So that's why the first thing, this one. If I try to using the first element of the array, so this one I'm using the, so with the pointer you will see here will become PTR. Then we see, are they still the same? Right, you see here, with the pointer equal to the beginning of the array name. So that's why I use the dereference. They are all the same. They can be referred to the first element. So then continue. Okay, I can using a dereference, right? I also can using the second element through the array. Okay, so remember second element of the array, I can do this way, right? I can do numbers 1. So I'm using the array name using the index, so they should display this 20. But now how about I'm using the second element? I want to show you the pointer just work exactly like your array name when they're assigned. So that's why here I can using the pointer. So this pointer name actually I can associate with my square bracket as well. So then I can display the second element of the array actually using the pointer symbol. So you see they can associate with this square bracket. So then they will equivalent to like this. So that's why you can see your first element equal to 10. I can either using the asterisk or I can using the square bracket. But let's try the square bracket for the second one. I can using the array name with the square bracket to access the second element. Or I can use the pointer because the pointer already assigned equivalent to the beginning of the array. So this example actually show you the array name actually work exactly like the pointer. So sometimes we can assign the array name just through the pointer variable. And also the pointer variable can associate with the indirect operator. So does our array name. So array name can associate with the square bracket operator. So the same thing, our pointer variable can associate with the square bracket operator to access the element one by one.